today, and you've got Kendra Little, as you can see there on the webcam, who will be doing the session, Why is that data wrong today, with a long subtitle of How Choosing the Wrong Isolation Level Causes Bad Results. So stay tuned. We'll go through a little bit of an intro here, and then I'll turn it over to Kendra. This is part of the PASS 24 Hours of PASS, which is 24 consecutive live webinars that are put on by expert speakers in the PASS community. The session will be recorded, and you'll receive an email when the recordings are available that you can actually listen to it afterwards as well. My name's Steve Wake, and I'm the moderator of the session. I am a local user group chapter leader here in the Denver, Colorado area, and also a previous speaker at other PASS events, including Summit in previous years, where Kendra has presented as well, and will be presenting at Summit this year as well, which is what this session is all about. And go ahead and go, yep, there we go. So if you need any technical help during the session today, feel free to use the pane on the right to actually type in any questions that you might have, and either Kendra or I will address them. If there's stuff that pertains to what she's currently going through, she may answer some of them during the session. Otherwise, we will have a Q&A session at the end where we can go through as many of those questions as possible. You can also use the controls to zoom your screen. Just use that button that's located at the top of the presentation window to actually zoom in. And when you go to close the session, when the webinar is over, you will be prompted for a short evaluation. So make sure you actually fill that out to give us some feedback on how we're doing with these sessions. And just know that that will pop up as soon as you close out of the webinar. Next thing is to actually thank our sponsor, Quest Software, that's out there to actually help with any of your database needs. So please, if you're looking for anything in that area, look at Quest Software, and they can help you out with that. And we thank them for being a sponsor of this session, because without them, we would not be able to put on these free events like this and any of the other events that PASS offers, which actually is the next slide. There we go. So yes, for PASS, make sure you go to pass.org, which I'm sure most of you have already, because that's how you registered for this event. But know that there are a bunch of other events, some of them in person, some of them virtual. The biggest in-person event is the PASS Summit that we've been talking about, that's on November 6th through the 9th in Seattle this year. Kendra and I will both be there, so make sure you attend. And then there's the PASS local user groups, like I said, that I actually run one in Denver here as well. So if you are in a area that offers a local group, you should attend those as well for the more local content. And then there's SQL Saturdays that are all over the world as well. SQLSaturday.com is the web address for that. Virtual groups, more of these type of marathons. And then there's just being a volunteer to do any of this kind of stuff, like what I'm doing as far as moderating or helping out PASS in many other ways. So with that, I will turn it over to Kendra. Oh, you're muted, Kendra.
There we go.
There you are.
Thank you so much, Steve, and thank you for running a user group as well. That is fantastic work for the community. My name is Kendra Little from SQLWorkbooks.com, and what I'm talking about today is, why is that data wrong? We're talking today about isolation levels. I'm really excited at the PASS Summit to be giving a full day pre-conference session on isolation levels in SQL Server. And this is information that throughout my career, learning about isolation levels and understanding what can cause data to be inconsistent, which most of our customers aren't going to say inconsistent. Most of our customers are going to say it's wrong. Understanding isolation levels and how to get correct data, consistent data back when I need to get it back, has been one of the foundational things that I've learned that has served me well as a DBA, when working with developers, when talking to business owners, because this question of, can we make sure the data is correct? That goes to the highest levels of the business. So features may change in SQL Server. Features will change. Features are going to change from, day to day sometimes, much less year to year. But the need to understand isolation levels, that's something that we need just for our careers for the long term. It's not going to go away. This need to understand, what do I need to do to make sure that when it really matters, the data is correct. In this session, we're going to just talk about why this is important. Why is it so easy that we can get inconsistent data back in SQL Server if we just use the default settings? We'll talk about why we have isolation levels in general. This isn't just something SQL Server has. This is something that is a concept and an important thing to specify when it comes to data in general. We'll also talk about SQL Server's default implementation of the read committed isolation level. We'll put it into context. Why do we have this and what is it like? And then we'll spend time in demos. We're going to do 2 demos of how easy it is to get inconsistent data back, data that when you look at it, you're like, but that's just not right. We'll look at how easy it is for that to happen and why that can happen in the read committed isolation level. These demos are not showing you bugs in SQL Server. These are not things that the SQL Server team doesn't want you to know about. In fact, these are things that the SQL Server team has blogged about for years, and they've given us many options to change things to make sure we do get consistent data back, but there are trade-offs with the choices we take. So we will then go to next steps. How do we begin? Because there are trade-offs. If we want to make sure we get consistent data, there's going to be something we have to do or give extra behind the scenes, and we'll have to make sure that that's right for us. So this is the adventure we are taking in this hour. And first up, what are isolation levels? What is this term and why have it? Well, I think about isolation levels as a concept this way. There's really important questions about how a database should behave when we have multiple users doing things at the same time, when we have concurrency, when I can read data that you're writing or you can write data that I'm reading. What should happen? So let's say that you are connected to our database and your transaction is modifying data. At the same time that you're modifying data, I come along and I have a query who wants to read the exact data that you're modifying. Well, what should I do? How isolated should I be from your modification? Should I wait until you're done and read the data after you finish your modification? Well, what if you're modifying multiple tables? Should I wait until you're done with the whole thing? Should I go ahead and read the data as you're modifying it? Should I do a dirty read and actually read the data mid-change? Should I do something else? Is there another copy of the data that I can go read somewhere else so that I don't have to wait? This is what isolation levels determine. Your isolation level as a reader answers the question of what should happen if you want to read data that someone else is writing. And then conversely, what if I am reading data and someone else at the same time I'm reading that data, they want to modify the data as I'm reading it? Should they have to wait until I'm done? Is there some other way that this could work so that they don't have to wait until I'm done? What should my transaction do? Should my transaction put protective locks around the data so that no one else can touch it? Right? Is there something that even as a reader, my isolation level determines how am I reading the data and how is this going to impact people who want to modify it? And this is why isolation levels are incredibly important, because even if you think, oh, well, I'm not specifying this, right? I haven't said what to do with this. If you haven't made a choice, you have chosen the defaults. You are making a choice about isolation levels, whether you are aware of it or not. And the database settings also impact what the default choice is. So if you aren't explicitly setting your isolation level, you are choosing to go along with the defaults, which may be influenced by how SQL Server has been configured. The default isolation level in SQL Server is a specific implementation of an isolation level called read committed. This slide shows what are called, I call these classic isolation levels in SQL Server. We've had these isolation levels for a very long time, and these aren't the only isolation levels in SQL Server. We'll see later on that we do have some more options, but if we think back to the early days of SQL Server came with isolation levels from lower isolation to higher isolation. And these are all what's called pessimistic. SQL Server's pessimistic isolation levels, the way they're usually termed, I tend to think of them as more fear-based or worry-based, because these isolation levels are, when I read from a table, the default isolation level of read committed, it is highlighted in yellow because the default implementation of isolation levels, when we just connect to a database, it defaults to a pessimistic version of read committed unless we change it around. If we're in this fearful or worry-based version of isolation level, when I read from a table, I'm going to take out locks as I'm reading. And the locks are there because I'm worried that someone may come along and modify the data while I'm reading it. Like, I'm afraid that something might happen. This can cause blocking. You may have seen in SQL Server, you may have seen code that contains little no lock hints, or you may have seen statements that say set transaction isolation level read uncommitted. People do that because even in this default isolation of read committed, people have problems with locking and blocking, and it generally doesn't happen right away with our database. Generally, we have our database around for a while, and then as we get more users, as we have more writes and reads happening at the same time in our SQL Server, we start to have locking and blocking problems where people are delayed and they're waiting for a lock. And one of the responses that people take, they do an internet search and they read, oh, well, if you use the hint no lock, then it will reduce your blocking. No lock isn't technically no locks. There are still some locks taken out by no lock, because even if I'm going to read a table and say, if I say, I want to use a no lock hint, what I'm saying is, even if somebody is changing the data, just give me whatever you see. It doesn't matter if it's consistent or not. It doesn't even matter if they commit their change. Like maybe their change will roll back. I don't care. Just give me what you got. But I'm still going to take out schema stability locks against that table so that while I'm doing my read, nobody drops the table or modifies the schema of it. So there are some minimum locks involved even in read uncommitted. But as we're going to see in the presentation today, what I'm going to show you is that even in the lockier version of read committed, there are still some very weird things that can happen. And what weird phenomena means is data that your users can look at and say, that just doesn't look right. That looks wrong. And the problem with users looking at data and saying that looks wrong and then asking us about it, and we're like, oh, well, if you rerun it, the data will be right. The problem there is that then they just don't trust our data, right? And the more critical this data is, the more that it's about the customer's sales, the customer's money, the customer's performance, that feeling of mistrust, the seeing of weird things can happen in this database, that is not a feeling that you want them to have, because they just aren't going to trust your data. If they feel like, oh, run it again and it'll be right is the answer. Maybe they run it again and it's still weird. Now, these classic isolation levels, we do have ways to say, I don't want all these weird phenomena that can happen. I don't want ghost records showing up or non-repeatable reads showing up. You can raise your isolation in SQL Server, but what raising your isolation level does with these classic isolation levels is it says, okay, well, maybe I need to hold my locks for longer during the transaction. Maybe I need to take out a new kind of lock so that locks a whole range of data. And that, it's great in terms of reducing weird data that goes back, but it's a big problem when it comes to having fast performance, because the longer I'm holding my locks, or the more things I'm locking, including a range, the more things I'm locking, the more things I can potentially block if I have modifications going on. So classically in SQL Server, we had this choice. Would you like data that looks wrong, or frequently? Would you like that to happen more frequently? Or would you like to have more blocking and potentially deadlocks? So of the isolation levels on this slide, that's why it's not an easy choice. That's why we don't just put a hold lock hint on everything or raise everything to serializable isolation level, because then concurrency gets more and more difficult and performance is difficult. For many folks, even fighting blocking and getting good performance with the default implementation of read committed is quite difficult. And again, this says pessimistic read committed. I think about this as like fear-based worried read committed. The way this is implemented by default in SQL Server, if I'm reading the data, I think, and I am anthropomorphizing the SQL Server here. It's one of my favorite like Jeopardy words. But if any query that's reading the data is like, oh, somebody may want to change it, so I'd better take out some locks. I'm not going to try to lock everything because I'm not quite as locky as these higher isolation levels, but I'm going to take out shared locks and I'm going to hold them for a brief amount of time. As I'm reading the data, I'm going to lock it. And while I'm locking it, other people can read it. I'll let other readers read it. But if somebody wants to write it, they're going to have to wait if they want to change this data. But as soon as I go past the data, I am going to release those locks. I'm not even going to hold the locks for the entire duration of my query. If I'm reading through an index that has a lot of pages, if I'm scanning on that index, I don't lock the entire index. I roll through it and have locks just held in a shared way as I go by. And this fact that read committed uses shared locks held for a brief amount of time is why, one of the reasons why it's so easy to have results that look wrong. And in fact, I would say, I mean, technically, whether they're wrong or whether they're inconsistent, I'll leave that to you to judge. I actually think that with the demo I'm going to show you, there is a very good argument that it's wrong. The demos that we're using today are using the Babby Names sample database. It is named Babby Names instead of Baby Names, just to show that this is, I mean, it contains some real data, but it's whimsical. This database is for having fun, playing around, and learning. The data that it contains is from the United States government. Every year, they release data about actual babies named in the United States for the prior year. We're using release 1.3 here, which contains information from last year, which was released recently. They release it around Mother's Day every year. I am doing a fresh restore of the database and replacing my existing database. The script will be available for download, and you will need to, unless you also like to use an S drive, you will need to adjust where you are restoring the database from, as well as where you're restoring it to. We are going to, for our first demo, create a non-clustered index on the ref.firstName table. Ref.firstName is a small table that contains a list of unique first names that have been used between 1880, I believe, and 2017. It has a first name ID that's a clustered primary key, and it has a first name column that I believe is varchar 128. We're creating a non-clustered index on the first name column. And if I look at this index, I'm going to look at the index structure using an old friend that we got in SQL Server 2005. We got sys.dmdb index physical stats. One of the main uses people use this for is to check how fragmented is that index. I don't care right now how fragmented the index is. What I'm doing right now is just looking at the page count and the record count. I've had it do a detailed look at that. And I just want to see how many levels does this non-clustered index have and how many pages and records does it have. In the leaf of the index, we have two levels of the index here. We have a single root page of the index that points to 249 child pages. Here they are. In the leaf of the index, we have 249 index pages, and on those pages, there are 97,310 first names. So our index is a tree with just one root page, and then we've got 249 pages, all ordered simply by first name. This index is on the key of first name. So the A's are at one end of the tree, and the Z's are at the other end of the tree. We are going to be running an update continuously that does two updates, and we will be moving or updating. They're actually, in this case, the same thing. We will be updating the name AABAN. We are going to update this name so that one update will run and it'll change it so that it begins with Z. And then another update will run that makes it back to the original name of AABAN. So this name will be constantly moving in the structure of the index from the first page to the 249th page, was it? And this physically moves the page, or this physically moves the row from one page to the other. We can see what page it's on if we want to with undocumented functions. This undocumented function is FN physloc formatter is what we're using here. What I'm saying is I want to see in ref.firstName, I'm forcing it to look at the non-clustered index that we're using. If the first name is one of these values, because we're updating it to ZZZAABAN, what I'm saying is show me with this undocumented function, this is not a supported function by Microsoft, only useful for testing in a non-production system, disclaimer, disclaimer. But where is it? What data file is it in and what page is it on? And we can even see what slot it's in, which is really cool. So before I update it, right now the name is AABAN. It is currently on page, it is in data file 1, click to select the whole column. So let's rezoom there. I am not the world's best zoomer. I do my best. We're in data file 1, we're on page 12,456, we're in slot 0. Slots are 0 indexed. Now I update the row. And what we're doing here is proving that it's physically moving to a different page. I have now changed the to be ZZAABAN, and it happens really fast. If I now look at who has the row, we are now on page 12,805, slot 371. So let's copy and paste this out. We're now at 12,805. If I update the row again and move it back to AABAN, and now check my row count again, we're now back at 1, 2, 4, 5, 6. So these are the 2 page numbers that our row is going to bounce back and forth between, because what we're going to have is we are going to have in another window, I'm going to set up this query to be running updates back and forth. We will be moving this row to 2 different parts of the index, the very beginning and the very end. Now, I haven't started this up yet. We're going to come back and start it up. While that row is moving, it moves in the table. It doesn't simply move in this index. Yes, the row in the table has a clustered primary key. The row will be updated in both places, but we are looking at this non-clustered index because we will be counting the number of rows in the table while the row is moving back and forth. I'm going to run this query. This is a simple count star query, and count star counts the rows. It doesn't care about null values. And in fact, we don't have null values for first name. Right now, no updates are happening. So right now it counts 97,310. Looking at the execution plan, SQL Server was able to perform this count by looking only at the non-clustered index that we created. It's looking at the ref.firstName non-clustered index. It isn't going to the base table. This non-clustered index covers the query. And what SQL Server does is if it's got to count all the rows, it looks here and it says, well, I'm going to have to scan something. That non-clustered index on first name is smaller than the base table, so I may as well scan that. So here is our counting query. I'll start up the updates here. So while the updates are happening, we're updating it to Aben, Zaben, Aben, Zaben. We are going to count the rows in the table, and we are counting the rows, and then I'm going to stop this and start again because I left my actual plans on there. I've now turned off my actual plans. I don't want to load test Management Studio displaying execution plans. So I've restarted it, which is fine. At the beginning, it creates a table named name count. We are counting the rows in ref.firstName 1,000 times and putting what we counted into name count. We have finished up our counting, and let's look at what we counted. And while we're here, I'm going to go ahead and attempt to stop the updates on the table. There we go. Query canceled by users. How many names did we see in the table? Well, we did see the right number of names 326 times, so that the answer was correct. If we round up 33% of the time, we undercounted the number of names 455 times, and we overcounted 219 times. there were always the same number of names in the table. I am not running a delete here. I am not running an insert here. I am running an update. I simply was moving that name. But SQL Server only saw the correct amount of rows in the table 33% of the time, if we're being generous with our rounding. Now, in terms of the number of names born, yeah, that might look fishy if that was wrong. What if what I was doing was summing up the total amount in someone's bank account or something related to financial values? What if I have multiple queries in the same report and they don't all add up together? This inconsistency in data, these counts are just not correct, right? They are inconsistent counts. And to me, that data is just wrong. Now, how much does it matter that the data is wrong? It's going to vary depending on the nature of your data and the temperament of your customer. So it can mix. It might not be a big deal if it's okay if the data is wrong, but I find that tends to be a minority of the cases, a small minority of the cases when, yeah, it's okay if the data is wrong. Here's a graphic about what happened and why this works. On this slide, the bird holding the lock, as it moves across the table, this is our read query who's doing the count. As it moves across the table, the lock moves with it. So as we're reading, we're letting go of locks. Right now, it started the read and it's in the middle of the table. It has let go of the locks on the pages of the index that it's already scanned. We've started our read. We counted rows back here, right? Here's Aben. AABAN is right there. We've already counted the row for Aben. Now we're continuing our scan. We're in the middle of the table. And meanwhile, an update happens. An update comes in and it changes the name from Aben to ZZZABAN. To make that change, it doesn't actually have to race us. It doesn't have to scan this whole index. It says, oh, the A's are here. I am going to modify this row, and now it's ZZABAN, and it's over here. If the page is full, it may have to, reallocate a page, do a page split, things like that, but it is going to move that row, and it can easily get ahead of me. So now, when my scan gets to the end of the index, because I'm in the default implementation of read committed, I'm just locking what I'm reading. And after that update completes and releases the lock, I'm going to see ZZZABAN there, and I'm going to count that row again. I have no idea that it's the same row I already counted. This is how that double counting can happen. And the inverse of this is how the undercounting can happen. If the update is updating ZZZABAN to the A's, I can miss it entirely and undercount. If more than one modification is happening at the same time, this can get even crazier. And the reader in this default implementation of read committed has no idea that, oh, I saw this row twice. It has no idea that an inconsistency has happened. Very simple to show this, very common for this to happen. And as a developer or a DBA, how would you even know if this was happening to your user until they send you a report or a screenshot of just really weird looking data? But it can get even weirder. This is another one of the ways in which read committed, this default implementation of read committed, allows really weird inconsistencies in the SQL Server. This inconsistency has to do with how query execution is implemented, and it also is due to this short nature of the way that locks are held and the way that read committed in this default implementation, it will wait for locks to be released. If someone else is modifying data and I come along, I am going to wait until they're done and wait until they release their locks. This is the read query that we are going to be looking at in our demo. And the important thing is that it does a hash join. So we're going to look at the demo real fast, and then we will return to the slides to see a visual of how it happened. Because this one is kind of a weird thing to even understand what went on and how the data could have been like that. I'm dropping the index from our last demo. We are going to use different indexes for this demo. And just to show you how weird this is, I am configuring a table in our sample database as a temporal table. So I'm using system versioning on ref.firstName so that we can go back and see what was the committed data at different times. I have added what I need to add to the table. I have enabled system versioning on the table. And I'm going to create 2 non-clustered indexes on the table as well. We have a non-clustered index on last report year, and we have a non-clustered index on first report year, and they contain different columns, last report year, etc. And I've just given it, this is a poorly named index. I apologize. It's just so that it's easier to identify when we're looking at the execution plan on screen. Please don't be like me and name your indexes with etc. in the index name. That is definitely poor form. But the first index contains last report year, first name, and first name ID as the keys. And the first report year, etc. index contains first report year, total name count, and first name ID. When we run a query against this table, SQL Server has many different ways it can run the query. We're going to turn on actual execution plans here so that SQL Server will give me a map and show me how it decided to run this query. What I'm looking at here is names that were new in 2017. My table contains a first report year column and a last report year column. I want to see the names that were reported first in 2017 and last in 2017. Technically, I could just use the first report year column, but just to make sure, we're using the last report year column as well. The top name here, we're ordering by total name count descending. The top name is absolutely my favorite name in United States naming history, with some exceptions. There are some names from like Battlestar Galactica and all sorts of fun names in here. But people in this country love Camrys so much that we now have started naming babies after the Toyota Camry. I can only believe that this is after the car. And, you know, I'm a Subaru person. This session is not sponsored by a car company, but now I'm tempted to have a pet named Subaru. But yes, my favorite name is Camry. I love creative names. I'm a name nerd, and there were 91 of them in 2017. And this query is executed in an interesting way as well. Not only do I think the names are interesting, I love the way the query is executed as well. SQL Server decided to use something called index intersection for this. It decided to look at 2 non-clustered indexes and to join them using a hash match inner join. I'm only querying one table, and SQL Server could have scanned the clustered index of this table to get all the information, but it said, oh, well, you know, part of the information is in the first report year, etc. table, and part of the information is in the last report year, etc. table. So I can seek on both of those. So I'm going to just look at these 2 non-clustered indexes and combine the data. SQL Server can choose to do this. It does not always choose to. This first table, this first seek, this will be executed first. What a hash match inner join is doing is it's building up some objects in memory, and it's going to take the first input, which is called the build input, and put that together first, and then it's going to go run the probe phase and build up its second amount of data in memory. And this is important because it means that we can get data from this first table, and then we can be blocked right here. Let's say that someone is modifying data that is in the columns for last report year, et cetera. Maybe they're updating the last report year. That isn't going to lock this index if this non-clustered index doesn't have last report year in it. So we could read part of the data and then get blocked on the other part of the execution plan. And this pattern and this fact that I don't know what they're going to do, I'm going to release the locks on this index after I read it. I'm going to release the locks on first report year after I'm done. I don't know what the modification who modifies the other index, I don't know what it's going to do after it releases those locks. It could come modify what I've already read. And that's why things get bizarre. So let's take a look at this, and we will use that versioning table to verify what was the data at different points. Here's how our story begins. We have an update that starts out in a transaction, and it's looking at that row for Camry, and it's doing a correction. It's like, we actually had the data reported wrong. people were actually, they weren't naming their baby Camry, they were naming their baby Toyota with an H, because we like to be really creative with our names now in the United States. So we're going to do that correction. And they actually have another correction they're about to make, but they're doing it as two statements. They aren't worried about it because it's within a single atomic transaction, right? Well, right after they do that first update, we happen to have a user who starts querying the name data, and they get blocked. They start their query, but notice that executing query is just going on and on and on. That probe phase of the execution plan is actually, it needs the first name in there, and it is blocked by this update that's happening. Well, we're not going to be blocked forever, no worries, because the update query has just one more change to make. It is also going to update the total name count, and then it's going to finish up. For this same row, they've just updated the name, we were also wrong about the number. There were actually 5,000 of them, not 99. The update finishes up, and when they finish up, our select query becomes unblocked. Here's the select top 100. The select query comes unblocked, and what we get back is a row that says the name Toyota, there were 91 babies named Toyota. Well, this is only half of the update. The previous row, and what I'm going to do is I'm going to look at, we're going to use that, the fact that it's a temporal table is now going to come in handy. I'm going to open a new window here, and I'm going to carefully arrange my windows so that I've left this query as it is. This is the results we originally had, and I'm going to now do a new vertical tab group so that we can compare the data history on the right. On the right, what we're doing is we're looking at for system time all. I want to see the data using the temporal history of the table. I want to see the history of the data for this first name ID. It gives me the committed version of the history. At first, the first name was Camry, and there were 91 of them. Later, the first name was Toyota, and there were 5,000 of them. Looking at this table, at no time were there 91 Toyotas. That is not a change that was ever a fully committed change. What happened in our query over here is that for this row, we read the total name count first, and then we read names that had been modified in a transaction later. And what we got back is an inconsistent combination of data, where if someone came to us and was like, why are they seeing this data in their report? Because we updated this data in the transaction, and they're seeing part of the data before and part of the data later. If someone had a fishy looking report like that and they showed it to us, a lot of the time we wouldn't even know why. If we have some sort of auditing, or if we have a temporal table, we would be able to look back and say, okay, well, at first this was the data, and then the data was changed to this later, but there's no in between here. So if we're lucky, this is actually very difficult to troubleshoot and figure out what the heck happened in the SQL Server. If we have the ability to see the full history of the data, maybe we can figure out, but it's going to be really puzzling because that report contains data from in the middle of a transaction that was modifying data. Here is a graphic that goes over how that works. We have a hash join and two non-clustered indexes on this table, and the build phase of this is going to go first. The probe is going to go second. Our query starts reading this table. We read from that index at the top, and we build up the build phase of our data in memory to do that join, but we're blocked when we go to the other index. Because we are just waiting for that lock to release, and we haven't held any locks on that index that we did the seek on, we aren't making sure that if we read that data again, it would be the same. No, we're in the default setting of read committed. We are just like, okay, we are just waiting on this lock here. That's all we're doing. We aren't reserving any locks. So when that lock gets released from that write, we then go read the first name and the last report here. So what you see at the bottom of the slide here is the data in yellow we got during the build phase. The data that isn't highlighted in yellow, we got modified data that isn't transactionally consistent with when we started the query. After we're done reading the data, we have left the other modification clear to go update the data that we've already read and finish up its transaction. And it happens to update total name count to 5,000, but we don't see that, even though that number is consistent with the first name change. So we get first name equals the data after the change, but we have a total name count that's the data before the change. And this can be, the more sensitive your data is and the more sensitive your users are, this gets to be more and more of a problem. And if someone brings us this data and we look at the history of the data, we're like, how could this even happen? This can happen under the read committed isolation level. And the worst thing that your user, the last thing your user wants to hear when they give you data and are like, why is this wrong, is we don't know. They want to hear that you know why the data would be wrong and that you have a way to prevent it from being wrong again. So this is the screenshot that we saw there of data from two different points in time appearing in the same result. Well, what do we do about this? We do have options in SQL Server. We have more than the classic isolation levels in SQL Server. Way back in SQL Server 2005, we got alternative implementations of the read committed isolation level. That should be singular. We got an alternative implementation of the read committed isolation level. We also got a version of isolation called snapshot. And I like to use the word versions coming out here because both of these newer isolation levels use row versioning so that we don't have to be as fearful anymore. We can be more optimistic. Those terms, pessimism and optimism, I tend to think of them as fear-based and optimism. Now, if I change the implementation of, I can change the default isolation level in SQL Server. I can say, I want this database to default to read committed snapshot isolation. If I do that, readers are not going to block writers, writers are not going to block readers. And that's kind of a bit of marketing terminology there, to be honest. But what it means is that when I'm reading data, I'm not going to be like, oh, I need to use all these shared locks because you might change it. And I still have to use some locks for safety. I need to make sure nobody drops the table. But SQL Server is going to have made some versions available for me. If I change the isolation level to read committed snapshot for a database, when modifications happen, SQL Server is going to generate versions in TempDB. It's also going to use timestamps. They aren't quite as simple as timestamps, but little stamps on the table that can help when I'm reading through that table. It can help SQL Server see, has this row been modified since you started doing your read? If so, hey, check out the committed version of the data in TempDB. Similarly, I am able to see, has the data been modified in the course of my transaction if I'm using snapshot isolation? The higher one here, it's higher on the screen and it's closer to serializable because with snapshot isolation, it's not the same as changing the default isolation on the database. What you can do is enable people to use snapshot isolation. If you enable them to use snapshot isolation, they can say set transaction isolation level snapshot. And if they do that, they can do an explicit transaction and they can have data be consistent with the first time they access data in their transaction. Now, why would you want to do that? Imagine that I have a financial report that contains 3 sections, or let's say 5 sections. It contains a section for each quarter, and then it contains a total for the past year. I may have queries in the report that run serially to get that data. First, I do quarter 1, quarter 2, quarter 3, quarter 4, and then I do the full year. What if data is being modified in the current quarter and it's included in that report? I want everything to add up. That is why I might want to say snapshot isolation, begin tran. I want everything to be consistent with the first time I'm reading from the data. All of my queries will then match up. And if I'm using snapshot isolation, I will be using versioning to get that done and the little timestamps that aren't really timestamps instead of taking out big old key range locks to get it done. There are reasons that we wouldn't just change these. You might wonder, okay, well, why have this session? Like, why talk anymore about this? Why not just say, okay, we're going to change the default isolation level to read committed. And when we have a multi-statement transaction, we want to be consistent. We're going to use snapshot, end of story, end of day. Well, there are interesting trade-offs. If you skip testing on these, you can run into problems. If I skip testing, and this is true with any isolation level change. If I just raise my isolation level to serializable, hey, forecast may call for deadlocks. If I just enable read committed snapshot isolation on a database, I may run into interesting race conditions. And by interesting race conditions, I mean I may have incorrect data showing up for different reasons now, because some of the queries in my application may have been written with the assumption that readers would block writers and writers would block readers. The simplest example of this is a queuing table, but there are many other examples that you can have where if suddenly we remove blocking and the readers just read they read committed versioned data instead of waiting for a write to complete, suddenly things start going haywire. This is not just a, hey, this might happen to somebody somewhere, but the chances are really low. I do know people who have just enabled read committed snapshot isolation and then had to revert it because they made the data wrong or appear wrong in a new way. So we've got to be careful. We've got to test. Even with snapshot isolation, things can go wrong. We might have it leak to people who we didn't think would use snapshot isolation because of connection pooling. We have to be careful. We have to plan the change. What we want to avoid is grumpy meetings. So don't just change all the isolation levels and hope for the best. There's absolutely good ways you can do this and you can make things a lot better. You just want to do your due diligence, do your homework, and implement it gradually in a way that makes sense, depending on what your application is like, what your users are like, and what phase of development the application is in. First step, the step to take after this presentation is you want to evaluate all your applications and check, I hate to use the word truthiness, but I do love the word truthiness. How much truthiness is required? This question may need to be answered by a high-level person in the company to see how much truthiness is needed. But there are some cases where I've had the CIO sign off. And if people are saying, oh, the data doesn't have to be right, I would go up the chain pretty far to say, look, here's our understanding. This data can actually be wrong, and you're cool with that. You want people to sign off on that if that's what they're saying. It tends to be pretty darn rare. You also want to know when modifications happen to the data. If you're the lucky person who has a system where, hey, we're offline when the modifications are happening, nobody reads it while the changes are happening, hey, you don't have to worry, right? Because nobody's reading it while the data is changing. That is becoming less and less frequent as well with the internet, with 24/7 access, with people working constantly around the world. And then you want to identify what isolation levels are currently in place. Is our code riddled with no lock hints? What isolation levels are we using? So that is where to start. And that is also how you help to prioritize what the most important isolation levels are to change. So I'm checking out the Q&A box here, and I don't have a ton of questions. If you do have questions, please feel free to go ahead and throw them into the Q&A box there. And what I'm going to do is move on. Like, your questions are still welcome. It's not that I don't want them, but I do want to advertise the next session, which is going to be awesome. Writing PowerShell with VS Code by Rob Sewell is going to be amazing too. So if you don't have questions or want to see Q&A, then you can totally jump out and get a drink of water before the next questions. If you've got questions about, it could be anything about isolation levels, it could be anything, you could ask questions about indexes, you could ask questions about corgis, whatever you want, feel free to show them into Q&A while we're still here. It doesn't show me if anyone's typing.
Yeah, no, they're flooding in now. You asked for it.
Oh, maybe my screen just isn't updating.
Yeah, the one that's been there the longest is what isolation levels recommended for an operational reporting environment, like on Dynamics AX that's suffering from locking.
Oh, okay. So I think I just don't see the questions at all. I may have to have you read the questions. My Q&A box is empty.
That's very possible. So, yep, okay. That's one of them. Yep.
Good to know. Okay, so say it again. So it's Dynamics AX.
Yep, and they're having locking on the reporting, so they're asking what kind of isolation level, which I'm
Okay.
confused on whether they're using the actual transactional database for reporting, which would be bad, but
Well,
sometimes
so
no way around it, I guess.
yeah, more and more the world that we live in is that people want up-to-date results right now.
Right.
They don't want to wait for an ETL to run. They want to know what is the data right now, and if we won't give it to them, they'll find someone else who will. So it's a tough situation, and isolation levels can help with that. Now, with a vendor product like Dynamics AX, what we need to know is what isolation levels are supported to use, because like I said, if we just go change the isolation level to something that isn't supported, we can run into trouble. My memory, and this is a vague memory, I would totally double check this, is that one of the things you may want to check with Dynamics is that I believe it sets its isolation level on the connection strings of the app. And I think it may use serializable, but I don't think it has to use serializable. So the first thing that I would look at, you can look at in the in sys. I think it's sys.connections, maybe. It's either sys.connections or sys.sessions. You can see what their isolation level is set to there. You could also go look at the connection strings. So that would be my first thing to check out there, is what isolation level are you using, and then look at what are the options there. I don't recall if Dynamics will support the newer isolation levels like read committed snapshot isolation. It is possible that they do, but I'm not sure.
Right.
I'm not sure. It should be something you can figure out from the Dynamics folks.
Right. Let's see, what else do we got here? What is the root cause to connection pooling?
Oh, what is the root cause to connection pooling? So the issue that can happen with connection pooling that I've seen before is that when a connection is reused in the pool. So with connection pooling, the idea is that, we use connection pooling to keep from having 8 million connections open to our SQL Server that then, sit idle and we're always connect, disconnect. So we have a pool of reusable connections. And the issue that can happen is that when the connection gets reused, it doesn't always reset the isolation level. So if you're saying set transaction isolation level snapshot and you're doing a bunch of work, and then you don't say set transaction isolation level read committed at the end, that connection that reuses it may use snapshot isolation level and then be doing things that are like updates, and they actually didn't need snapshot isolation. Maybe they run into update conflicts or different issues. So the thing you can do is reset your isolation level when you're done doing your work, or you could just split it. If you have a certain workload that you want to use snapshot isolation, they could use, their own connection string, and you could have all others use a different one. You could just totally separate them out as well. So kind of different options and approaches to it. And it kind of depends on how your session pooling is managing things and whether or not it will automatically reset the isolation level for you. So it is a problem you can solve. You just kind of want to be careful.
Right. A couple questions about what do you do or recommend when there are a lot of no-lock hints in all the queries? There's
Well, you're not
actually
alone.
3 of them, that have asked that, so it's common.
First, I recommend meditation. Drinking is also an option. Maybe the meditation first, and then after the drinking, after you get over that. So it's a difficult answer is why I preface it that way, because one of the weird things that can happen is when you put a no lock hint in your query, you're directing it to use no lock. And even if I change the default isolation level for my database to that read committed snapshot implementation, it's still going to honor the no lock hints. So if you leave all the no lock hints in your code and you say, hey, I want you to do all this versioning SQL Server, it's going to do all the versioning for you. And then when your query runs with no lock hints in it, it's going to be like, oh, I'll just do a dirty read. I won't go use the version. There is an exception to this. The one exception is on availability group readable secondaries. Isolation levels are escalated to snapshot isolation. We'll do a whole demo in the pre-con about how exactly that works and some of the oddities, because it doesn't come for free, but it will ignore no lock hints on the readable secondary. It's the only place we'll ignore the no lock hints. So maybe that's an option for you to be like, oh, we'll just run them all against the readable secondary and hope for the best. But other than that, the recommendation is you do need to, if your solution is to implement read committed snapshot isolation, you do need to remove the hints. if you want to start using snapshot isolation, you need to remove the hints and set the isolation level to snapshot. So I wish there was an easier answer, but.
Right, because there's a similar one where somebody's asking, how do I get rid of an app with 9,200 no-lock hints? Scan and search and replace is a great tool.
Well, and I would remove them gradually. So depending on how you're solving it, I mean, sometimes, to be honest, you can solve blocking problems with indexing. There are other solutions we can get to that we don't always have to change our isolation level to solve blocking. But so one of the funny things is you will never be able to get rid of no lock hints entirely because Management Studio uses them. So as long as people are using Management Studio, if you're searching like your query cache on the SQL Server, you're going to find them. You can remove them from your own code, but they're going to get in there into the cache for Management Studio too. But I would go through and especially, I mean, the more correct the data needs to be. So evaluate, okay, what parts of the application are the most important to hit first, and we're going to start. Here's our plan to make sure we don't end up in a big blocking situation, whether it's an isolation level change or an indexing change, whatever you choose, and then we're going to roll through and start removing these from the code base. Yeah.
Yep. Let's see. Most of the rest of them are about how do you prevent deadlocks.
I love it.
Of course.
I love it. So how do I prevent deadlocks? Preventing deadlocks and solving deadlocks are different things. My favorite tool for short-term solving of deadlocks, like if I have a deadlock and I want to keep it from coming back, my favorite short-term tool is indexing, figuring out if there's an indexing change I can make to change the route of those queries so they don't deadlock anymore. But if the question is preventing deadlocks, if I don't want them to come start attacking me, isolation levels are absolutely what I would do. And this is part of why when you're designing an application from the beginning, don't just go with this worried, pessimistic implementation of read committed. Start out optimistic so that you get all your code tested that way. Start out with read committed snapshot. And at the beginning, just say, we're going to monitor for the problems that can happen with this, if our version store gets backed up or et cetera. But we're going to start out optimistic so that any of the code patterns that might have these race conditions, we just won't code that way. So that is my favorite method for saying we're going to build an application that isn't prone to deadlocks. But if I'm in a reactive mode and we're already using, pessimistic isolation levels, then for break fix, indexing is my favorite short-term break fix, just because we have to do a little more legwork to do a full-on isolation level change. Yeah. I actually am at the point where I think deadlocks are fun, which is kind of an illness.
All right. Well, I think that finishes those up. So yeah, as we said, everybody, thank you for attending, and yeah, make sure if you're interested in Rob Sewell's session next about PowerShell with VS Code that you switch over to that. Otherwise, feel free to listen to any of those sessions. There's a whole bunch more of them. I think we're only through the first 7 or 8, so there's still a lot to go before we get to 24. So yep, see you all later, and if you want to put up your contact info slide there, Kendra, next, you can put that up. So if anybody has questions, there's her Twitter handle and her email. So other than that, thank you all for attending.
Thanks so much, folks, and thank you very much for hosting, Steve. Much appreciated.
No problem. Thank you.
Okay, bye, folks.